Hi, welcome to a mystery teardown. What the hell is this thing? It's not an Illudium Q36 space modulator. Let's check it out. Yes, we're going old school, and thanks to Charles at Trio Test, we've got ourselves a Philips PM5639 colour analyzer for those playing along at home. And this is an old school bit of test kit. Comes in the original carry case. Fantastic. And let's take a look at it. What do we got? We've got ourselves the detector, which is designed to plug on the front of our CRT monitors, and as the name suggests, it analyzes the color to see if all the colors are accurate and the spectrums are right. It's got a nice, sexy little control unit that comes with it, and it looks like we've got ourselves the original brochure, is it? No, well, it's part of it. There we go, CRT Color Analyzer. And these would have been the duck's guts at TV stations back in the day for calibrating all their studio monitors and stuff like that. Maybe they still use them, you know, some old school places. Philips used to make a whole range of, you know, various audio and video analyzers and all sorts of stuff for, you know, setting up production, measurement, test, all that sort of stuff. The old analog composite waveform monitor, check it out. Loudspeaker powered audio monitors, pretty fancy. It looks like they've, you know, this is fairly modern stuff in the scheme of things, but yeah, I'm not sure when this color analyzer dates from, but yeah, it's basically no one would use it anymore, but it's probably still worth a pretty penny to someone who, you know, absolutely still needs it. But there we go. There's our operating manual. Hi to all my Danish viewers. Beauty. Made in Denmark, is it? But all the original manuals, there it is. I mean, that's an old, check out the old CRT TV that they're actually monitor that they're testing there. That is hilarious. Oh my goodness. To our customers, on January 23, 1998, Philips TV test equipment has changed its name to Pro Television Technologies, or PTV. Who knew that? Yeah, I guess they, look to sell it off for pennies on the dollar for what it used to be worth. Good day, Moritz von Toll. Good on ya. There you go. Check it out. Wow, copyright 2000. It says recent, printed in Denmark too. Thank you very much for playing. So this is actually surprisingly recent, although the model dates back to, you know, God, that's got to date back to the early 80s, I would imagine. And maybe early to late 80s, and but they were still selling this in 2000. Now, I used to work at Key Corp back in 1994, I think it was, and working on LCD monitors and things like that. So they're just starting to take over. You know, 640 by 480 was, you know, or 800 by 600 was absolute state of the art, and it was real difficult. But 2000, I mean, yeah, okay. I still had a CRT TV in 2000. I'm pretty sure I did. Geez, I mean, how long did it last after that? Not very long. I wonder if they're still going. Check it out. We even have the calibration data for our CRT color sensor. CRT matrix, what does all this mean? I have no idea. Protected data, is that the data that's stored in the internal E² PROM? I would imagine. It's traceable to NIST. No wuckers. So this is a rather intimidating bit of kit. I mean, look at that. That is fantastic. It's got the suction cup to stick on there, some sort of photo sensor in there, which is, of course, you know, carefully, I'm sure it's very expensive, and it's quite expensive to get it calibrated as well. But there's not probably a huge amount more in there. Last calibrated in 2002, but you'd stick that up and stick it on the CRT monitor and get an accurate, to see the spectrum and your color values, so that you could get in there with your tongue at the right angle and tweak your RGB values to get your monitor the right color. I used to work with a guy way back at Pacific Communications back in the day who had calibrated eyesight. I kid you not. You know, job was they would be their eyesight would be certified to actually look at colors on the CRTs and know that they're accurate. It's got the correct color, the hue, the saturation, and all the brightness or whatever, you know, and they could basically do it by eye. But this is basically, you know, pretty much replaced people with those calibrated eyesights, I think. And yeah, you know, you have a numeric value that you could get with this thing. So let's actually try and, before we'll violate the rule and we'll turn it on before we take it apart, shall we? It comes with a little plug pack with a weird ass attachment. It uses a rechargeable NiCad nickel metal hydride battery pack, but let's try and switch it on, initialize in, and bingo, there you go. There's your RGB values. I've got that sitting up. I'll stick it on the, whoop, there we go. Yeah, I've got it face down now, so it's not receiving any light at all. And we can get our, look, candelas per square meter. Believe that you can't use this on like a modern LCD panel. It wouldn't work. It hasn't got the right color attributes and everything else. It's designed for CRTs. I believe they did have versions for LCD monitors. They probably still do to test the color, because, you know, you get one of those professional color monitors these days. I'm talking about the multi-$1,000 professional monitors that are all color balanced, color matched and things like that. Well, they've got to test that. And, you know, presumably they stick on something similar. So if I point this up to my lights up here, my studio lights, there are nominal 6,000 Kelvin. Color temperature, RGB is fairly well matched. I mean, I could, you know, a spectrometer's much better. I could get my spectrometer and hook it up. I did that in a previous video, didn't I? There we go. Temperature around about that 6,000 Kelvin. So that's, yeah, that's pretty spot on. Ensuring a high standard of picture quality has become even more important with the increasing interchange of program material from different sources such as TV studios and production houses. The Philips Color Analyzer assists in this process by meeting the demand for easy control and adjustment of the color white and the brightness on any color monitor. Beauty uses an adaptive system to establish the correct measurement independent of the field rate. The instrument works with all field rates, HD TV systems, progressive and interlaced systems. Bobby Dazzler. The main application is to align the color of white and brightness color monitors in studios, OB vans, outside broadcast van for those not in the know, post-production, etc., measuring monitors, surveillance monitors, RGB computer monitors, consumer TVs. And here's our XYY measuring mode here. This is plotted on a chromaticity diagram. It's a mouthful. And the X and Y values and the luminance value Y and the color error, CIE, love, hence why it's called CIE, are shown in the numerical display. User can select a preferred measuring unit of luminance, candelas per square meter, nits, I like the nits, or the foot Lambert. Or you foot Lambert fanboys, come on, admit it. Who's a foot Lambert fanboy? Now, if you're wondering how this works, you can actually set up this box. You can have pre-programmed different setups, specs that you want. And this box, you actually want your dot to be inside that box, inside the RGB matrix with the luminance and the XY value. So it's got to match your pre-programmed one. So I can stick it up there to the lights and boom, bingo, we are inside the box there. Smack bang in the middle. So that's, you know, whatever we've got it programmed up to, yeah, we're certainly meeting it. Inspect, ship it. And here's an interesting characteristic curve. We've got a portion of the CIE 1931 XY chromaticity diagram showing the daylight locus, the Planckian locus, importantly, with a few ISO temperature lines. Obviously, makes perfect sense. So the field of color, imaging, spectrum, and luminance, and all sorts of stuff is actually quite complex when you get into the physics of it. And I've done several videos on that before, touching on that sort of stuff. So yeah, it's a rather interesting field, and of course it all comes down to physics. There's our battery pack. Anyway, yeah, that's enough. I won't pretend I know all about color television, you know, reference checking and stuff like that. But let's have a look what's inside this thing. Won't be a huge amount. This will have a micro in it. Be interesting to see which one. And this will probably just be a sensor and some driver sensor electronics, something like that. And you bet we're going to break the warranty void if not removed sticker. Here we go. Let's get in there and will we be in like Flynn? Oh, no, we had a spring. Okay, we have a spring in there for the trigger. That could end badly. Yeah, we're off. Yeah, there's a little bit of stuff in there. Whoop. Yep, the trigger is, yeah, what's going on there? Yep, broke it. Oh, brittle plastic, it's old. So let's have a squiz inside here. Of course, it's all in the calibration of this thing. No, that comes up. Oh, actually, that's rather interesting. Ta-da! We have 3 separate ones, RGB. It makes sense, does it not? That you would have separate RGB ones with different filters down there. Look at that. Oh, get a close-up on that. Now, I'm going to guess that these photo sensors are all identical, and the way that they are, of course, one's for R, one's for G, and one's for B. And the way they do that is to have the filter in there. There you go, and you can see that they are actually different. They would be the RGB. Yeah, so that'd be the red, that'd be the green, and that'd be the blue, even though they don't necessarily look 100% like it on here. But yeah, that's how they're doing it with these little lenses. I won't bother taking... I don't think there's anything else under there really, but hey, why not? And if you're wondering why they're all angled like that, it's obviously so that they focus in one point in the center like that. I don't know what the actual field spot size would be. Hey, maybe it's in the specs. I don't know. But yeah, it's designed to focus on one little spot there, because there's no point if you're aiming, one here, one here, one here. That's, too far apart. You've got to aim for the correct space on the CRT itself that you want to measure. So it's a spot measurement thing. There you go. That's a better look at the filter lenses for those playing along at home. This is what faces the CRT, and they're the red, green, blue lenses. Aren't they beautiful? They're probably worth, a pretty penny, I would say. That'd be a very specialised bit of kit. I wonder what the, the spectrum bandwidth of those are. I don't know. Does anyone know? Does anyone want to hazard a guess as to, how narrow the filtering is on these things? But anyway, they do look really jazzy. I love that. And on top of that, in case you were wondering, is just what looks like, I'm sure this is kind of special too. I'm not sure what's going on there. Looks like something's happened to that. I don't know, but yeah, that looks kind of sort of special as well. And maybe the front part of that as well. So, yeah, there's lots of spectrumy magic happening through these 3 layers here. Well, it turns out we don't have to wonder, because I've got a spectrometer. So let's actually use my spectrometer to measure this. We've got our filters here, our red, green, and blue filters. I've taken the front part of that off, but we can measure that separately. And you've seen this spectrometer before on the blog, and here we go. I've got my little torch here just to make a bright and broadband sort of source. It's not, this is not completely scientific. This is not the best thing, but we're getting a reasonable coverage there. It's going up into the red as well. It's peaky, but it'll do the job. So let's actually hook this up, or actually I'll show you. You can see that's red filter. There's the blue filter. Maybe it's not going to show up well on the webcam, but that's blue. And that's green. Fantastic. All right. So, yeah, that actually did show up. So let's actually shine our torch through. Here we go. What do we got here? Blue. Okay. So if we hook up, you'll notice that we're getting absolutely nothing when I point it away. So I've got the gain set so that, there we go. Bingo. That's the bandwidth of our blue filter. Now, I'm not sure what I was expecting. There may be something a little sharper than that. So, it's going from 400 to 550 nanometers or thereabouts. And of course, if you put it back through like that, it's more broadband than that. There's, you know, there's still content below 400, but, you know, like you've got to get the gains right and everything else. I'm just mucking around here. So it's not, certainly not the best scientific experiment, but you'll be able to see the bandwidth. And likewise for the green one, bingo, there we go. It's chopping out, you know, from mostly from, say, 500 to sort of 700, 650 or thereabouts, certainly in that green spectrum there. And, of course, we are clipping a little bit, of course. It's hard to... Oh, there we go. You know, anyway, you can see. So the green is a bit wider in terms of bandwidth than the blue one, I'd say. No, maybe not when you include that little aqua hump in there. Aqua hump, word of the day. Let's try the red one. And that, hello, that is surprising. The red one, there's still, there's yellow content there, I guess. But what is the blue doing? The blue is almost the same. Well, it's not almost the same, but, you know, it's getting up there towards the green peak. So why it's letting through blue in the red filter at like 450 nanometers there, I don't know. That is quite strange. And then it's, you know, its main peak is about 580 nanometers in the green spectrum. Basically where we, you know, not far off where we, basically the same where we were before. So I'm not sure what the deal is with that red filter. It is very unusual. If anyone knows what's going on there, I'd have to look into the physics behind that, think about it a lot more. But anyway, that's interesting. Saw the bandwidth. Now let's take this filter material and look at that. There we go. That filter material is taking out all the red. What the? Why? I mean, this is a red, green, blue. What? Give me a break. That's just ridiculous. Now, that's... Whoa, there we go. Hang on. So, wow, okay. That's the similar sort of response to what we saw with the red. And with that, and this just, it's given the same response. What the? Oh, no. Okay, no, there we go. That's our white. So that's our spectrum. Maybe, yeah, this lead isn't the best. I think maybe that's what's going on there. We don't have enough. Yeah, because it's auto-gaining. We didn't really have anything in the red to begin with. Like, there's some there, but because of the gain and everything else, no, we need a better light source. But why it was passing that blue through, fascinating. So there you go. But they're the filters that we've got inside this thing, and you really saw like the blue one, for example, blue and green, very nice bandpass performance on this thing. So there you go. That's the filters. Neat. Ooh, wonder if you can still get the service manual for it. And for those who just can't get enough of the specs of this sort of thing, the measurement range, there you go, accuracy, and look, there's the repeatability, the luminance, RGB bars better than 1%. Oh, terrific stuff. And it even has a learn mode if you don't know what particular phosphor of the monitor that you're actually testing, because that's important. So do the filters inside here actually parallel the color response of the human eye as defined by CA 1931 standard observer curves? That's probably what they're attempting to do here, because that's the thing. What do us humans actually see this monitor as? I mean, that's the important thing. You can do all the measurements you want, but, you know, if we think it's out, then it's out. And just a close-up there for those playing along at home. Ooh, psychedelic, man. And we have Hot Snot, thank you very much. And what have we got over here on the board? That is, we're going to have to get our knife out for that, aren't we? Have we got a little Phillips, probably, you know, like an 8051 or something? Do we have an 8051? Come on. Let's cheer. Do we have it? 87C51, I called it. What else would you find in this puppy? But apart from that, and they were, looks like they were a fan of some Maxim parts there. And they'd be line drivers, of course. Dead giveaway right near there. I don't know why they put the vertical resistors in there like that. That's rather hilarious. Oh, hang on. What's on the bottom of that resistor? It's weird. It's got a purple thing. What? Wow, they've actually gone to the effort to put a sleeve on the bottom of that. I am doubting that's a resistor now. I think that puppy's an inductor. And of course, you've got to hot snot your sensor in place, don't you? Can we get a part number? A nice little plastic holder for that, but I don't see a part number on there, do you? No, bummer. Anyway, if anyone can identify that, quite a large sensor die in there, isn't it? Just got the one bond wire you can see going over there, and that is really interesting. But like I said, all of those would be identical, and all the filtering is of course happening on the front. So they would be, you know, wideband, photo sensors of some description, and of course they'd be doing all that filtering with those front lenses, however wide the bandwidth is for the RG and B. But that's pretty much all she wrote for the sensor board. It's got a fair bit more than I expected in there, so it's obviously digitizing all that. 8051, was there a little ADC on there? Oh, there might be somewhere a Philips ADC. Come on. Wow, yep, there it is. They got some serious business happening here. This is a TC500A. That's not the microchip symbol, but I pulled up, when I Googled that, pulled up a microchip data sheet. This is an analog to digital front end. It's an entire front end up to 17-bit ADC with, pretty much the whole shebang inside that thing. So that's an interesting bit of kit. Date code 17th week 97. So let's open the main controller here. Hopefully I got it all out. We had an 8051 before. Look at the contacts for the battery just soldered directly onto the back there. We've been mooned. We've been mooned. We've got to get it out. So we had an 8051 before, but that's all you needed, just to send that, packetize that ADC, control that ADC and stuff, read those values, send it over the serial line. They were getting power over that line, of course. So let's, got a board to board there, yep. Single in line, I love single in line board to board stuff. And we're in, like Flynn, have we, there we go. Ta-da! We're in like Flynn. There's our LCD stuff. Oh, Toshiba. I was going to say, probably Sharp Jobby, but not. That's a Toshiba. And what do we got down here? Good old-fashioned micro, because we've got ourselves a ROM. And all the best stuff's made in Japan. What on earth is that? Said 1330. Aha, there we have it. Philips PCF 80C31. Basically the same as the 8051, except there's no ROM built in. Hence, well, we've got a separate ROM there. Checksum, 7900. Seems too even to me. Sure enough, that said 1330. You googly that one, and it's an LCD graphic controller, of course, because, this is just for driving the segments. So you've got to have the actual controller itself. So this is, pretty old school stuff. I'd love to know where this, when this design originated from. It would be maybe early 90s. It could be the late 80s perhaps, but obviously they were making this into the 2000s. And I'd like to know when they discontinued it as well. So there you have it. That's the Philips PM5639 Color Analyzer. Thanks to Charles for donating this one. It was just going to get tossed. It's like so old. You can't find anyone to really who wants this sort of thing anymore. But hey, the technology would still exist for modern calibrating modern LCD monitors and stuff like that, I'm sure. But yeah, CRT's gone a little bit the way of the dodo, but I don't know. If you're still using one of these, or when was the last time you used one of these, let us know. Leave it in the comments. Anyway, I hope you found that mystery teardown interesting. I certainly did. Hope you enjoyed it, and if you did, please give it a big thumbs up. Catch you next time.